So Rutherford's model was a failure. So Niels Bohr modified Rutherford's model and he explained two important developments to explain Bohr's model of atom. Before explaining those two important developments, we have to discuss the failure, some of the failures of Rutherford's model. First point, Rutherford's model failed to explain the stability of the atom in the light of electromagnetic theory proposed by Maxwell. In the structure of atoms, we know electrons are revolving around the nucleus with very high speed. So they emit certain radiations. This was explained by Maxwell through his wave theory. In that he explains about electromagnetic radiation also. Okay, those theory clearly explains the stability of the atom, but Rutherford's model could not explain this electromagnetic theory by Maxwell. This was the first point. Now second point is Rutherford's model could not explain the existence of certain definite lines in hydrogen spectrum. Okay, later we are explaining about the hydrogen spectrum and different spectral definite lines, certain spectral lines in the hydrogen spectrum. This Rutherford's model could not explain the existence of these definite lines. It's the second point. Now the third point is Rutherford's model could not explain the electronic structure of atom. What is meant by electronic structure of atom? Rutherford's model explains that there is nucleus and electron is revolving around the nucleus. He could not tell anything about the energies of these atoms, these electrons in the atoms. Okay, this is called as electronic structure of atom. Electronic structure of atom, they explains clearly about the energies of electrons in the atoms. But Rutherford's model could not explain this. Okay. So next we are discussing about the wave nature of electromagnetic radiation. So Niels Bohr modified Rutherford's model due to its failure in order to introduce he introduced two important developments to explain Bohr's model of atom. These are the two important developments. First one, dual character of electromagnetic radiation, which means the radiation possesses both wave nature and particle nature. Okay, here we are discussing the wave nature of electromagnetic radiations. Okay, so electromagnetic radiations means while electrons, subatomic particles like electrons are revolving around the nucleus, they possess certain radiations because they are moving at a very high speed, and these radiations are emitted by the electrons. Okay, these radiations possess both wave character and particle character. Okay, this was the first development made by Niels Bohr. Now the second development is about atomic spectra, which explained by assuming quantized electronic energy levels of atoms. This we will discuss later. Okay, now we are discussing about the wave nature of electromagnetic radiations. So wave theory was proposed by Maxwell. This was proposed by James Maxwell in 1870. In this he explains about electromagnetic radiations. Electromagnetic radiations. What is meant by electromagnetic radiations? When electrically charged particles moves under acceleration, alternating electrical and magnetic fields are produced, and these fields are transmitted in the form of waves. These waves are called electromagnetic radiations. So what is electromagnetic radiations? When electrically charged particles like electrons, okay, when electrically charged particles moves under acceleration, alternating electrical and magnetic fields are produced. alternating electrical and magnetic fields are produced. Okay, magnetic fields are produced, and these are transmitted. Okay, so when electrically charged particles moves under acceleration, alternating electric and magnetic fields are produced and transmitted. These fields are transmitted in the form of waves. These fields are transmitted in the form of waves. Okay. These waves are called as electromagnetic waves or electromagnetic radiations. Okay. These fields are transmitted in the form of waves, and these waves are called as electromagnetic waves or electromagnetic radiations. Okay. This was proposed by James Maxwell in 1870. Okay. So before the discovery of this wave theory, Newton introduced corpuscular theory. In this theory, he explained the light waves are moved in the form of corpuscles. That means particles only. And they did not explain anything about the wave nature of light waves. Okay. Here, Maxwell explains the wave nature of light waves. So Maxwell explained light waves are associated with oscillating electric and magnetic character. Okay, so different properties are: first one, oscillating electric and magnetic fields are produced. Oscillating electric and magnetic fields are produced by oscillating charged particles. Okay, produced by oscillating charged particles are perpendicular to each other. And both are perpendicular to the direction of propagation. Both are perpendicular to the direction of propagation. We can explain this by using this figure. X-axis shows the direction of propagation of the waves. Okay, this wave contains two components. This oscillating particles contains two components. This radiation contains two oscillating electric and magnetic fields. Okay, these electric and magnetic fields produced by this electromagnetic radiation are perpendicular to each other. From this figure we can see that this y-axis represents the magnetic field, which is one of the component of the wave and of the radiation, and z-axis, this wave represents electric field and the other one represents the magnetic field, and these are in y direction and z direction, which means that these are perpendicular to each other. Also the direction of propagation is along x-axis. So these two are perpendicular to the direction of propagation of waves. So in this figure also shows that the frequency, the wavelength, then amplitude, speed, etc. all these two components of these electric and magnetic fields are same, only their direction are different. Okay, their direction means they are perpendicular to each other, and these two components are perpendicular to the direction of propagation of the wave. Okay, now second property, unlike sound waves, water waves. All these needs a medium for their propagation. But electromagnetic waves do not need a medium. Do not need a medium. And they can move in vacuum. They can move in vacuum. Okay. This is the second property of electromagnetic radiation. Now, third property. There are different electromagnetic radiations which differ in their wavelength. Okay. There are different electromagnetic radiations which are differ in the wavelength, which constitutes the electromagnetic spectrum. Which constitutes electromagnetic spectrum. This electromagnetic spectrum we will study later. Okay, this is the third point. So, there are different electromagnetic radiations emitted by the subatomic particles which differ in their wavelength and which constitutes the electromagnetic spectrum. Now, fourth point. These radiations contains different kinds of units. Okay, this electromagnetic radiation used to represent by different kinds of units. Okay, different kinds of units are used to represent electromagnetic spectrum. Okay. These are the different properties of electromagnetic radiations explained by Maxwell. Okay.